transformed views of society and nature. In his work Novum Organum Scientiarum, or New Instruments of Science, published in 1620, and is a development of Aristotle's treatise on logic and syllogism, written in the latter's book Organon, Bacon outlined a new system of logic to improve upon the old philosophical process of syllogism. Bacon's method relied on experimental histories to eliminate alternative theories. He promoted a scientific method in which scientists gather many facts from observations and experiments, and then make inductive inferences about patterns in nature. For Bacon, finding the essence of a thing was a simple process of reduction and the use of inductive reasoning. As an example of the Baconian method is this. Let us say that one would like to find the cause of a phenomenal nature such as heat. One must list all of the situations where heat is found. Then another list should be drawn up listing situations that are similar to those of the first list except for the lack of heat. A third table lists situations where heat can vary. The form nature or cause of heat must be that which is common to all instances in the first table, is lacking from all instances of the second table, and varies by degree in instances of the third table. Let us now look at another persona who I think you have heard of in your high school days. René Descartes. We recognize him by the saying, cogito ergo sum. I think, therefore I am. René Descartes, who lived from 1596 to 1650, he was a mathematician, scientist, and philosopher who promoted a scientific method that emphasized deduction. These ideas, as well as his mathematics, influenced Newton and other figures of the scientific revolution. The discourse on the method of rightly conducting one's reason and of seeking truth is both a mathematical and autobiographical treatise published by René Descartes in 1637. He believes that all science is based on mathematics. This is manifested in his unification of ancient geometry and his new algebra based on the Cartesian coordinate system. He is respected for his attempts to create a form of philosophical argument akin to science or mathematics. His emphasis on a perspective of consciousness in epistemology and his work on methodology. Descartes believed that pure reason is superior to observation. It sparked the key debates in modern philosophy of science. For him, the only things that definitely exist were thoughts, because even doubting them is a kind of thought.
At this point, you're probably wondering, how about the history of science and technology in our country? Well, I will leave that to you to discover yourself. In your reading assignments, I have included an essay by Professor Dr. Olive Kawile, a former senior colleague in UP Diliman. We will also have an opportunity to discuss her essay in our scheduled online meeting.
In the early half of the 20th century, a very significant philosophical twist in the scientific method was championed by Karl Raimund Popper, an Austrian-British professor at the London School of Economics. He rejected the classical inductivist views on the scientific method in favor of empirical falsification, a view that a theory in the empirical sciences can never be proven, but it can be falsified. Realism, or logical empiricism, modified with the views of Popper, probably is the most received view of Western science in the modern period. So we come up to the question, then makes a scientific statement. So, what makes a scientific statement? Well, the irony of it all is that the one who laid the ground rules for judging whether a statement is scientific or not was not a scientist. This question has been brought to court in the United States. Judge William R. Overton laid a set of criteria as to what makes a scientific theory. In his decision, he said, first, it must be guided by natural law. Second, it must be explanatory by reference to natural law. Third, it is testable against the empirical world. Fourth, its conclusions are tentative. And fifth, it is falsifiable. The first two criteria has reference to natural law. Such a reference acknowledges that there are underlying uniformities and general relationships between phenomena which explains the behavior of things. The third criterion requires that claims can be observed in some way. If it cannot be tested, then it is not scientific. The fourth implies that no matter how much evidence we have found for our scientific theory, we must be open to the idea that it may be wrong and that new evidence may disprove it. This position is a position of David Hume, an empiricist, who argued that the scientific finding based on observations are true only insomuch as they have not yet been proven false. The fifth implies that theories should be stated in such a way that we can find evidence against them. What is the scientific method? The methodology of science is concerned not only with the discovery of knowledge, but equally also with the justification of knowledge claims. For knowledge to be termed scientific, a method of inquiry must be based on empirical and measurable evidence subject to specific principles of reasoning. The Oxford English Dictionary defines the scientific method as a method of procedure that has characterized natural science since the 17th century, consisting in systematic observation, measurement, and experiment, and the formulation, testing, and modification of hypotheses. The scientific method is the guide by which we find evidence to either accept or reject knowledge claims. Though the scientific method is presented as a series of fixed steps, it is best to consider that it is a general guideline. Not all the steps should necessarily be followed, nor the steps be always made in the same order. What is important to remember is that there are rules of scientific inquiry in each step. I will endeavor to make a brief presentation for each of these steps. Observations of the natural world are the triggers towards knowing and understanding nature. These observations lead toward the formulation of questions. Inquisitiveness is innate to us. No example is better than that of a young child who, in trying to understand what is happening around him or her, would throw us a never ending string of why, how, and what questions. Formulating a question pertaining to an observation of a natural phenomenon is perhaps one of the most difficult parts in any scientific inquiry. The research question may aim to find explanation to a natural phenomenon or may aim to find solutions to a problem presented by a natural phenomenon. A hypothesis is a conjecture, a probable answer to the research question or explanation of the phenomenon. That is based on knowledge obtained while formulating the research question.